Hey, what's up, guys? I'm just going to give you a little shout out to my Precal students. I have this binomial theorem exam review that I gave you in class today. Somebody said you wanted to see a video of answers, so I'm going to go ahead and put this together for you really quickly. Real talk. All right, so let's go ahead and take a look at this. Find the coefficient of x to the power of 5 of the expansion 3x minus 2 to the power of 8. So basically I'm going to take this binomial, multiply it by itself 8 times. Yeah, that doesn't sound like fun. I'm not going to do that. What I'm actually going to do is use the binomial theorem. I'm going to write this over here in the corner here. It looks like this. Let's see. Let's try a plus b to the power of n is equal to the sigma n k equals 0. And then we got the combination here, n and k, a to the power of n minus k, and then b to the power of k. Alright, so I'm going to reference this formula throughout this, so just try to follow along. This is a target they're giving me. They want a coefficient of this target. So I'm going to actually use this portion right here, just this part, to find k. Once I find k, then I can go after the coefficient. But I need to isolate this target here. So my a here, which is the first term of this binomial, is in fact, for me, 3x. That's the same thing as my a. So my a is 3x. I'm going to put 3x to the power of n minus k. That's what it says right here, n minus k. N is in fact this 8 right here. That's what n is. So it's really going to be 8. 8 minus k. Alright, it's not a very good looking 8, but let's try that. Okay. So, my b portion right here, this b is going to be for me a negative 2. So I'm going to put negative 2. It says right here to raise this to the power of k. So I'm going to raise it to the power of k. And this is going to equal something. Some coefficient that I don't know, and then it's going to be followed by the variable x to the power of 5. That's the target, remember, they've given me. I don't care about this coefficient right now. All I care about is the variable x and its power. So to do this, I'm going to use this variable x and this power to find k. Negative 2 to the power of k is going to give you a number. Remember, I'm not interested in numbers, I'm interested in the variables. So I'm going to ignore this for the time being. This 3 will be raised to the power of 8 minus k, but that's just going to give me another number, so I don't care. I just care about this. So basically all I really have that I haven't discarded is this part. So it's x to the power of 8 minus k. And this is actually going to be, in effect, equal to x to the power of 5. What I can deduce from this, since this is x and this is x, that 8 minus k is in fact equal to 5. If that's the case, then we know right away that k is in fact equal to 3. Because 8 minus 3 is 5. Fine. So now I have my n value and my k value. N is 8, k is 3. So now we're going to use this whole segment of the formula, and we're going to figure out what our actual expression or term is with x to the power of 5. So we're going to write nk. So nk, remember n is 8, nk is 3. All right, and then I'm going to say this is going to be multiplied by a over here. We're multiplied by a, but a is in fact for me what? 3x. So this is 3x to the power of n minus k. N minus k is 8 minus 3. 8 minus 3, most people would say, is 5. Okay, b is negative 2, so we're going to have negative 2 raised to the power of k. K we just determined is 3. Now this particular part right here, this is that combination thing we were talking about. I'm going to go ahead and just write it way up here. I'm going to say what this actually means is 8 factorial over 8 minus 3 factorial times 3 factorial. Okay, and what that basically means is 8 factorial is 8 times 7 times 6 times 5 factorial. And this is going to be over 8 minus 3 factorial, which is in fact 5 factorial times 3 factorial. These 5 factorials will cancel out. 3 factorial is the same thing as 6. It's 3 times 2 times 1. That's going to cancel out with this 6, so it's going to be 8 times 7, which is simply 56. I will not do that anymore. I'm just showing you what that means. If I were you, if I'm doing this, I'm actually going to open a calculator, and I would just type in, I would go to menu, and then I would go to probability, probability, combination, and then I would just do the n comma k. So that would be 8 comma 3. That's the same number, 56. Just keep that in mind. Alright, so 56 right here. It's the same thing, as I said. Alright, so we're going to go back and figure this out. I determined this is in fact 56. So I'm going to use a calculator from now on to find this. This is 3 to the power of 5, so we can't ignore that. We have to multiply this by 3 to the power of 5. It's really 3 to the power of 5. Now we have negative 2 to the power of 3. Okay. We know that's actually in fact negative 8. And then we're going to have, of course, the variable x to the power of 5. What I'm really just trying to figure out is what is all this. This is going to give me the number, which is the coefficient. So again, I'm going to consult the trouble. And I'm going to say, okay, I have 56 times 3 to the power of 5, and then times my negative 8, which is negative 2 to the power of 3. And that's going to give me this number, which is negative 108,864. And then I'm going to go back to this. And say, all right then. This is going to be negative 108,864, and it's going to be x to the power of 5. This is the term, but what I'm after is this actual number, which is the coefficient. That's what I was after, the coefficient. If you give me the whole thing, you get full credit. I'm just going to be looking for that number. So this kind of right here, we call this your answer. All right, it's that number right there. That's what I'm looking for. All right, that's pretty straightforward, so let's just do another one similar to that one, and we're going to do a few of these. Okay, so this next, alright, so we're going to do this again. We have a very similar problem, same process. So we're going to try to do this. We're going to have, we're going to find the coefficient of a cubed b to the power of 4 in this expansion. Alright, so we're going to use this formula we have up here. We're going to keep referencing that, and again, I'm just going to use these last two variables here in this formula to figure out my value of k. Once I find k first, everything else is going to be revealed from the same theorem. So my a value, this little a value right here for me is actually this first term, which is 5a, and the b value will be b right here. So this is going to be 5a to the power of n minus k. That's what the formula says, n minus k. N is automatically this number here, which is 7. I have no idea what k is. That's the whole goal. So we're going to find it, but we're going to put it as k right now. My b value is just b. It's the second term right here. And we're going to raise this to the power of k up here. So k, again, I don't know what that is, so I'm just going to call it k. And I'm going to set this equal to my target. My target is what they're giving me in this problem here. There's going to be some number in front of the target, a coefficient, but I don't know what it is, and I don't really care at this point. I'm just going to figure out what this is equal to. So I'm going to find this, I'm going to set this target here, but I'm going to ignore this number. I'm going to pretend it's like it's not here. This number here raised to a power will give you another number. I'm going to ignore the numbers. I don't care about the coefficients. I just want to find k. So I'm going to use just the a and just the b. So what I'm looking at is this part. It's going to be a to the power of 7 minus k times b to the power of k. And this is going to equal my target here, which is a cubed b to the power of 4. Now right away I should notice here that this b and this b are the same, and that k is more than likely equal to this exponent here, which is in fact 4. And that's true, and I can show that if k is in fact 4, like I'm saying it is, then we have 7 minus 4 right here. And 7 minus 4 should equal 3. And in this case it would, because it's going to be equal to this 3. So I know that k is equal to 4. Alright, so now I'm going to go back up here to this binomial theorem. I'm just going to use this whole thing, this whole portion right here to find the target. We're going to ignore the sigma. We're just going to look at this actual term expression. So n and k, this combination here, It's going to be 7 and 4. And then we got, again, a, which is my 5a here. This is my first term. Raised to the power of n minus k, which is 7 minus 4, which is 3. And then we got my second term, b, raised to the power of k, which we decided is now 4. Now we just got to figure out what this is. Now, I'm not going to go over this again. I'm not going to figure this out as a factorial expression anymore. I'm just going to use the calculator to save time for the sake of brevity. So what I'm going to come down here to do is, and I can go into menu. I'm going to go to probability, menu probability, and combination. And it's going to be simply 7, 4. And that will be 35. And that's the number I'm going to use in its place. Oops, so this is going to be, this number here is actually 35. And then now I have 5 to the power of 3. So we're going to multiply this by 5 to the power of 3. And then we'll have a to the power of 3 following that. And then b to the power of 4. So what I really just need to figure out is what this number is. What is 35 times 5 to the power of 3? 5 to the power of 3 is 125. So I'm just going to figure out what 35 times 125 is. And say, alright, 35 times 125. And that's going to be, 4,375. Alright, so this is going to equal 4,375. A cubed b to the power of 4. This is your coefficient. That's the number in front of your target. This again was your target. The coefficient is this part of the answer. So this is your answer here. This is what I'm going to be looking for when I grade test questions, that number for the coefficient. Alright, so let's go on to the next question. Alrighty. This one is actually a simpler problem because I'm looking at this binomial and it's just a and b. Okay, so we're going to have a target again, so we're going to find a. A is our a term right here. We're going to raise it to the power of n minus k. N is this number here, which is 12. So it's going to be 12 minus k. I have no idea what k is. Again, I have to find that first to reveal anything else. Now we have b after it, which is this second term, raised to the power of k, which I also don't know. I'm going to simply set this equal to my target. This is my target right here that they've given me in the question. So this is a to the power of 5, b to the power of 7. So what I'm going to deduce from this then is that since this is b and this is b and this is k and this is 7, that means k must in fact equal 7. And if that's the case, then this will be 12 minus 7, and 12 minus 7 is 5, which is nice because that's what that is in fact over here. So k is in fact in this case equal to 7. So now I'm going to come back up here. I'm going to scroll up here to show you this. I'm going to use this formula again, but I'm going to use just this part right here. I'm going to ignore the sigma. I'm just going to look at this expression. So n choose k for my combination. So it's going to be 12 and then 7 right here. This is just a number, a combination, and then we have a to the power of n minus k, so it's 12 minus 7, which we know is 5, and then b to the power of k, which is 7, which is actually the same thing as our target. So all I'm really looking for is, what is this? If I know what that is, I have my answer. So again, I'm going to consult the calculator, and I'm going to say, okay. I'm going to go to menu, probability, combination, and this will be 12, 7. That's going to be 792, which is great for me. So this will be 792. That's what this number is. And then we're going to have, it's going to be followed by its variables, a to the power of 5, b to the power of 7. This part is the coefficient that I'm after. So that's the answer to the question, this part right here. But if you give me the whole thing, that's fine. I'm just really just looking for this number when I grade your papers again. On this next question, we're going to go ahead and they're going to ask me to find the constant term of this expansion. So if I multiply this binomial by itself 9 times, it's going to give me a long-winded polynomial with several terms. But One of those terms is just going to be a number. There's going to be no variables in that term, and that's called a constant term. I need to figure out which one that is. And there's a little trick to this, but I'm going to go ahead and copy the binomial theorem again. And so just bear with me because we have to keep using this, and I have to keep writing it pretty much so that you can see it. So we're going to have this again in k, and we're going to have a to the power of n minus k and b to the power of k. We're going to keep using this theorem here. So I'm going to just use this portion here to figure out what k is. That's what I'm going to do. And what I'm going to do is, okay, this a part is x. That's all that is. We're going to raise that to the power of n minus k. That's what the theorem is telling me to do right here, n minus k. N is 9. That's what this number is. That's n. So it's going to be 9 minus k. My b is this part right here. And this is the trick to this sort of question. I'm going to rewrite this awful looking thing as a different exponent. It's going to be a negative 2 times x to the power of negative 2. This is actually identical to this. It's written in a different form with a negative exponent. So that's what I'm doing. I'm going to raise this b term to the power of k, and that's what that is. Now, this has to be equal to my target, and my target is a constant term. The only way I'm going to get a constant term is if I have x to the power of 0. X to the power of 0 is 1. 1 is a constant. That's why this will give you a constant term. So we're going to have this equal this. I don't really care about this number again, because this number raised to the power of k is just going to give me another number. I'm not interested in the coefficients. I'm interested in just the variables for now to find k. So I'm going to kind of ignore this or take it out of the picture for the time being. It'll come back momentarily. So I have basically x to the power of n minus k, and I'm going to multiply this by x. This time it's x to the power of negative 2 times k. So it's negative 2k. And this is going to equal x to the power of 0. Now the rule is when you're multiplying variables of the same base, you're going to add the exponents. So we're going to add these together. Okay? So if I go ahead and put parentheses around this and add this and put parentheses around this, I'm going to set this equal to 0. I have an equation up here. So I have 9. Okay, what I have is 9, and then I have negative k plus negative 2k, which is basically 9 minus 3k. And I'm telling you this is in fact equal to this exponent of 0. So now I have an equation here I can solve. What this really means now is that 3k is equal to 9, and then I can figure out now that k is equal to 3. If my k value is 3, it means I'm going to end up losing my variables if k is 3 for that specific term. And I'm going to show you why that happens. We're going to use this right here again. So n and k. So we have that. We're going to have n being 9. K I just told you is 3 down here. And then we're going to have a. My a term is this x right here. And that's the power of n minus k. So 9 minus 3 is 6. And then we're going to have this part right here, which I'm going to rewrite in a different way as being negative 2 times x to the power of negative 2. And we're going to raise this to the power of k, which is 3. Now we have to figure out what is this, okay? So this combination again, 9 choose 3. Okay, so I'm going to look back at my calculator. I'm going to go to menu, probability, combination, 9, 3. This will tell you that value very quickly, which is now known to be 84. Okay, so let's go back to this. This is 84. That's what this part is right here. Okay, and this is going to be multiplied really by negative 2 raised to the power of 3 right here. So negative 2 raised to the power of 3 is in fact negative 8. That's what that is. So I've used this up already. Okay, so I've used up this negative 2. I have x to the power of 6 now, times x again to the power of negative 2 times 3. Negative 2 times 3 is negative 6. What's going to happen again with this is if I multiply these x's, I'm going to have to add their exponents, and 6 plus negative 6 is 0. Alright, so literally what this is going to give me is 84 times negative 8 to the power, times x to the power of 0. This thing is the same thing as 1, so this is going to disappear and become 1. That's all that is. So this is just going to leave me a number when I'm done, and it's going to be 84 times negative 8. And all I have to do again is consult the calculator. So 84 times negative 8. I've double multiplied here. Don't do that. It's going to throw an error back, and it's going to be negative 672 without having to figure that out in your head, because I'm not quite that clever. Alright. So negative 672 is all you have. That's all that's left after all that work, and that is the constant term that you wanted. So that's that answer. Alright, we're moving on here. It says complete the following expansion. Whenever you're doing an expansion, if I were you, I would use Pascal's triangle. I'm never going to ask you to do an expansion with a power higher than 5. This one has a power of 4. So it's not going to be a terribly long thing to have to write out. So I'm going to go ahead and make Pascal's triangle here. And let's see if you guys can remember how this works. I'm going to extend the page here. And I say, okay, the top number is 1. Then you put 1s on either side of it. And then 1 on the outside again. 1 plus 1. We're going to add these, and that's going to give me 2. And I'm going to put a 1 on the outside again. Keep putting 1s on the outside. So 1 on the outside. 1 plus 2 is 3. 2 plus 1 is 3. And then a 1 on the outside. Another 1 on the outside for the next row. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then put a 1 on the outside to keep this pattern going. When the second number is the same as your exponent, you stop. We're done. We just need to use this particular bottom row. So I'm going to go ahead and get that started. I'm going to go ahead and write this bottom row right here. It's going to be as 1. This is my coefficient array right here. So it's 1, 4, leave some space in between them, 6, 4, and 1. And the reason I'm leaving space like this is because I'm going to have to write in some terms. The way the theorem goes is that I'm always going to have this term and then multiply it by a and b, and then it's going to have respective powers. My a in this case is 2 and my b is ax. So we're going to multiply these and write that after every number. So it's going to be 2 times ax, again 2 times ax, 2 times ax, 2 times ax, 2 times ax. Alright, and we're going to add these terms together because that's what the binomial theorem tells me to do. It has a sigma in its expression, so we're going to add. Now this a value starts off with the power, same number as n, which is 4. So this is going to have a power of 4 on this 2 here, but we're going to count down from there each term by 1. So it's going to be 4, 3, 2, 1, and it's going to end in 0. Okay, conversely, this one's going to start with 0, and it's going to count, in fact, up. So it's going to go 1, 2, 3, 4. Now all I have to do is simplify this expression, and I can figure out what my answer is. Ax to the power 0, anything to the power 0 really, is 1. So now this is 1 times 2 to the power 4. 2 to the power 4 is in fact 16. That's your first term. I already knew that though because they told me that right here. That's in fact 16. It should be the same. Here we have 2 to the power 3, which is 8. 8 times 4 is 32. So this will be 32 times ax to the power 1, which is 32ax. Again, I already knew this term because they told me right here. But now we have to figure out the rest of it. That's what they're really asking me. What is the rest? What are the next 3 terms? Is what they're asking me here. All right, so I'm going to put a plus sign. 2 to the power of 2, 2 squared is 4 times 6. That's going to be 24. If I say ax all squared, that's the same thing as a squared and x squared. Okay, and then we're going to keep going. 2 to the power 1 is 2 times 4, which is 8. Ax all cubed is going to be a cubed x cubed. Here we got 2 to the power 0, which is 1. 1 times 1 is 1. And then ax to the power 4 is simply going to be a to the power 4, x to the power 4. So what they're asking me for is to complete the expansion, and I did. And the completion is this 3 elements here. They gave you the first two already, which you see, and the rest of it is right here. So that's the answer. Good job. All right. So let's go on to the next set of problems. All right. This is the sequences and series questions. That's the fun part, right? All right. So a theater has 20 rows of seats, and there are 15 seats in the first row, 17 seats in the second row, and each successive row of seats has 2 more seats in it than the previous row. Okay, that makes sense. So calculate the number of seats in the 20th row. This is an arithmetic sequence, okay, because we're going to add the same number of seats to each new row. This first row has 15 seats, and the second row has 17 seats, so we've actually added how much? We've added 2 seats. And we're going to add 2 more seats each time we go up a row. So I'm going to use a formula for arithmetic sequence to find a term I want, which is going to be an to the power, an equals 1 plus n minus 1 times the common difference. Okay, calculate the number of seats in the 20th row. What they're actually telling me is that n is 20. Okay, n is 20, and what this is equal to will be the number of seats in that 20th row. All right, so we're going to say n is 20. That's what n is. A1 is the first row. 1 means first row, but A1 itself, okay, 1 is the first row, but A1 itself is the number of seats in the first row, which they tell me right here in the first row there's how many seats? There's 15. So A1 is 15. Okay, so this is the index. This is the first row, which means there's 15 seats. A1 is 15. All right, so n is 20, so this is 20 minus 1, which is 19. And then we're going to multiply this times d, which is the common difference, which we decided is 2. Alright, so I just have to figure out what this is. So this is, let's see, we got 20, and 9, it's 18, it's 38, 45. That should be 53 seats. Okay, let's put an exclamation mark. I'm really excited, okay? So that one is 53 seats. That's the answer for this one. Now it's going to ask me the total number of seats in the entire theater, okay? Very well. So I'm going to use the partial sum of an arithmetic series. Sn is equal to n over 2 times a1 plus an. All right. We know n is 20. That's the 20th row. So we're going to find out what the total number of seats in. As it turns out, the theater has, in fact, 20 rows of seats. That's what we're going to say n is 20. So this is going to equal 20 divided by 2. A1 is the number of seats in the first row, which is actually 15. Since n is 20, an, which is A20, is the number of seats in the 20th row. But A20 we just found is actually 53 seats. So that's what we did that for. So now we got to figure this out. 20 divided by 2 is 10. And then we got, let's see, we got 68 right here. So 10 times 68 is 680 seats. And the whole thing. Bam. All right. Good call. All right, let's scroll down to the next problem so we can keep this going. Write down the first 3 terms of the sequence. All right. For this, where n is greater than or equal to 1. So the first n value we're going to use is 1. So this is greater than or equal to 1, and then it's going to be 2 and 3. All right, the first 3 terms. So this is sort of like my index. So I'm going to plug in 1 for n. So 3 times 1, first number is 3. The next n value will be 2, so it's 3 times 2, which in fact will be what? It'll be 6, and then we'll plug in 3 for n, so 3 times 3 is in fact 9. This is your first 3 terms. All right, that's pretty much all it is. So you can put a smiley face. There you go. Really happy about that. If we go into part B, it wants me to find this, okay? And what this really is the same thing, really, right here. This 3n and this 3n. And they want to add, I gave you the first 3 terms, but they want me to add the first 20 of those terms if I kept this pattern going for 20 terms. And they want me to add all those terms together. That's what this really means. And you could do this, but really, in reality, the calculator is designed to do this and save you a lot of time. So I'm going to use that again. I'm going to go ahead and open up. I'm going to use that again. I'm going to open up the calculator. And once you get this calculator going, what you're going to do to get that sigma up is you're going to go to Menu. You're going to go to Calculus, actually, and it's going to say Sum. Menu, Calculus, Sum. And it's going to put in a sigma already for you. So this is going to be n equals 1. That's the start of your index here. And this is going to go up to 20. And this will be 3 times n, or 3n if you like. If you hit enter, it tells me that sum is 630. So if I add the first 20 terms of this sequence, it's going to give me 630. So I'm going to go ahead and write that in for my answer. The calculator told me that answer, and that's all you really have to do. Okay. For the next one, we could just repeat this process. Okay. What they really want you to do is something entirely different. And in fact, I'll probably explain it to you. Let me go ahead and find this answer first in the calculator, and then I'll explain to you how they probably really wanted you to do this. Okay. This problem when they designed it. So let's have a look here. I'm going to open up a calculator and just put this answer for you first. So I'm going to do the same process: Menu, Calculus, Sum. This time we're starting at a different index, which apparently is 21, and we're going up to 100. And then we got 3n. So that's a big number. It's 14,520. Very well. Okay. In reality, though, all right. Clara organizes cans in triangular piles where each row has one less can than the row below. For example, the pile of 15 cans shown has 5 cans on the bottom row and has 4 cans in the row above it, and so on and so forth. So I'm going to call this top row A1, and this will equal the number of cans it has. So this is row 1, and this is going to equal the number of cans it has. A1 is going to equal the number of cans, that's 1. So I'm going to identify row 2 by saying A2, and A2 is actually going to equal the number of cans. So this is the row. How many cans do you have? You have, in fact, 2. And this is going to keep happening. In fact, if I have this last row here, the 5th row, this is going to equal, in fact, 5 cans, because I count 1, 2, 3, 4, 5. So this conclusion I can draw then is that if I know the row number, which is n, it's going to equal the number of cans in the row itself, which is actually n. So the 5th row should have 5 cans, the 6th row will have 6 cans, the 19th row will have 19 cans, and so on. A pile of cans, there are 20 cans in the bottom row. So they told me something here. There's 20 cans in the bottom row. I'll actually know how many rows there are, because if there's the same number of cans as rows, then the bottom row is also 20, because there's 20 cans in that bottom row. So that bottom row is in fact the 20th row, is what I'm saying. Show that the pile contains 210 cans. They want the total sum of all the cans, so we're going to use a summation formula for an arithmetic sequence here. So we're going to have sum of n terms is going to be n over 2 times a1 plus an. All right. N is what? 20. We know there's 20 rows, so this is 20 over 2. The first row has how many cans, guys? It has 1. The 20th row, an. Remember, an and n are the same thing. So if I say n is 20, an is also 20. So I'm just going to put a 20 here. 20 divided by 2 is 10. 20 plus 1 is 21. 10 times 21, most people say, is 210, which is exactly what they wanted it to be right here. That's all they were asking you to do. All right. There are 3,240 cans in a pile. So they're now going to give me, what they're giving me here is the sum of all the cans. And they want to know how many cans are in the bottom row. That also means I have to figure out how many rows there are, if you want to think about it that way. So I'm going to use this formula again, but I'm going to substitute this number for the sum. So we're going to have 3,240 and this is going to equal n over 2, and this is going to be a1. Remember, a1 is the top row, which only has one can, and then this is going to be times n. And the reason I'm saying this is n and not an is because I've already told you that an and n are the same thing. Okay, I just said that right up here. All right, so I'm just going to use that. Oops. So I'm going to distribute this in here, and what I'm going to end up getting is 3,240 is equal to 1/2 n squared plus 1/2 n. That's what happens when I distribute this n over 2 into here. And I don't like these fractions, so I want to get rid of them by multiplying this entire equation by 2. That'll get rid of these little halves that are in front of me on this equation. So this is 2 times this. This is going to be 6,480. 2 times 1/2 is 1. That means it's going to go away, so now we just have n squared. 2 times 1/2 over here is also 1, so all we're going to have again is n. If I rearrange this equation on the bottom, that's going to give me n squared plus n minus 6,480 is in fact equal to 0. This is a quadratic equation. There are several ways to solve a quadratic equation. They include factoring, completing a square, or using the quadratic formula. I'm not going to use any of those because I'm trying to save time when working this out. So what I'm going to do is use a calculator and have it do it for me. So now I have my calculator. I'm going to go to Menu, Algebra, Polynomial Tools. When I do that, I'm going to find the roots of the polynomial. They're going to ask me what degree is a polynomial. It's a quadratic. It's degree 2. The number in front of n squared is 1, so that's the first coefficient, the lead coefficient. The number in front of n is also 1. And the last term, the last constant, is negative 6,480. Okay, so it's going to set up this polynomial. When I hit enter, it's going to give me 2 roots. The one I want is the positive one, so here we go. I'm going to use 80 instead of negative 81 because you can't have negative 81 cans or rows or anything. It has to be the positive, so it's going to be the 80. That's the answer that we're going to use. So what I'm going to say from this is how many cans are on the bottom row? There are in fact 80 cans. Which row is that? Well, we know it's the 80th row because the number of cans matches the row that it's on. So that's pretty straightforward from there. We go on to the next question. This is kind of the same thing we just did. There are S cans and they are organized in a triangular pile with N cans in the bottom row. Show that this is in fact equal to that. So I say, okay, the summation formula again is Sn is equal to n over 2 times A1. A1 is 1, that's the top can, plus AN. AN and N are the same. I keep saying it right here, right? So this is just going to be N. I'm going to do this again. I'm going to distribute this. All right. So they're calling this the sum. We could just call it S instead of Sn. We'll just call this S right here. So the sum, when I distribute this, is going to be equal to 1/2 n squared, and then n over 2 times 1 is going to give you 1/2 n. I'm going to get rid of these halves again by multiplying the entire thing by 2. So 2 times S is 2s. 2 times this half and this 2 are going to sort of negate each other and it becomes 1. So all you're going to have here is n squared, and then 2 times 1/2 is 1 again, so it's going to be plus n. If I rearrange this equation, I'll have n squared plus n minus 2s is in fact equal to 0. This is exactly what they wanted me to show. So there you go. Clara has 2,100 cans. Explain why she cannot organize them in a triangular pile. Well, this is a sum of cans. This is an S value, and I can plug this directly into S. It's the same thing going on here. So what I'll have is n squared plus n minus 2 times 2,100 is equal to 0. This again is n squared plus n minus 4,200, which is equal to 0. Now I have another quadratic, which I can use the calculator to solve quickly and figure out how many cans are in the bottom row. That's what it's going to tell me. Alright, so if I do this, I'm going to go to Menu. Okay, I'm going to go to Algebra, Polynomial Tools, find Roots. Degree 2 is okay. The number in front of n squared is 1. The number in front of n, and that polynomial is also 1. And then we're going to have minus 4,000, was it 4,200, I think? Yeah. And then we're going to hit OK. When I hit Enter, it's going to give me this. The number of cans I supposedly have in the bottom row is 64.3 and change. So let's think about that for a second. When I go back to this, okay, this means that the bottom row is going to have 64.3 cans. That is not good because most people don't have 0.3 cans. There's really nobody ever sees part of a can, so that's not good. So what I'm going to say then is I don't have an appropriate number of cans to make a proper triangle. Okay, I either need to take cans away from this total number that I have right here, or I'm going to have to add some cans to it in order to make a triangle that's appropriate. So, we can't make a triangle pile or triangular pile with this number of cans. We need less or more. So we need either more cans than that or less cans than the 2100 I have to make a proper triangle. Either way. Alrighty. This is the last page. Gwendolyn added the multiples of 3 from 3 to 3,750 and found a series here pretty much. And I'm going to analyze this real fast. I'm going to see that this, and this all have common difference, where each time we're adding 3, which is nice, okay? Because we're adding multiples of 3. That's what we're doing. That makes sense. All right. So we're going to identify some things here. We're going to say A1, this is your first term, is 3, and this is going to be your last term of the sequence, which is this one, AN. S right here, this is your sum, okay? They want you to calculate S. That's the sum they want you to find. There's a summation formula for an arithmetic sequence. We know it's arithmetic because we're adding the same number each time. And here's the formula. It's SN is equal to N over 2 times A1 plus AN. As it turns out, though, I do not know what N is. I don't know how many actual terms there are in the sequence. There's a huge gap in here, and I don't know how many elements are there. So I have to find that. And I'm going to find it using this formula. So we have to do two separate steps. We're going to say AN is equal to A1 plus N minus 1 times D. This is the general formula for finding any term of arithmetic sequence. A1 we know is in fact 3. Okay? Remember, I do not know what N is, so I have to keep it as N minus 1. The common difference is what we're adding each time, which is in fact 3. And AN, I told you, is the last term, which is 3,750. So if I go ahead and distribute this, I'm going to get 3n minus 3 here. I'm going to put a 3 up front, and it's going to equal 3,750. These cross out. 3 minus 3 is nothing. So now I have 3n is equal to this, so now I just have to go back and divide both sides by 3. So n is going to equal whatever this is divided by 3. That's going to be, by the looks of things, 1,250. Okay. So now I know my value of n for the sum formula, finally. Alright, so S, really we're going to call that S instead of Sn, is 1,250 over 2. A1 I already know is 3. And AN is 3,750. And now I have to figure out what this is. It's some terrible number. So let me use the calculator once more. I'm going to go ahead and set up a fraction. That's what I'm going to do. I'm going to say 1,250 over 2 times 3 plus 3,750. This is going to give me this terrible number, which is 2,345,625. Okay. 2,345,625. Let's see if I can remember that. So this is going to equal 2,345,625. That's pretty large. That's the sum of those terms, though. How many terms am I adding? Think about that. It's over 1,000 terms. Over 1,200 terms I'm adding together. And when I do that, that's what I end up getting. So it's kind of a large number. All right, we're on the last question. Find the sum of an infinite geometric series. We talked about this briefly. A geometric series will have if it's an infinite geometric series, if you add the terms forever, it will converge on a single value so long as the common ratio, or the absolute value of the common ratio, is less than 1. All right, so let's actually find the common ratio first before we get all excited about that. If this is in fact a geometric series, there's a common ratio. If I multiply this number by the first term by r, it'll give me this term, and then I multiply by the same r, and this one follows. So to figure out what r is first, we're going to actually say r is equal to this term divided by the previous term. So it's going to be negative 4 over 9 divided by the term in front of it, which was 2/3. When you divide by a fraction, you multiply by the reciprocal of the bottom, which is what I'm doing here, and I'm going to ignore this. So negative 4 times 3 is in fact negative 12 over 9 times 2, which is 18. This is in fact going to equal negative 2/3. That's what r is. So r is equal to negative 2/3. Now to find the sum of an infinite geometric series, if in fact r is less than 1, or the absolute value of r is less than 1, which it is, it's 2/3, we're going to use this formula. The sum of an infinite number of terms will equal a1 over 1 minus r. a1 is the first term, which is 2/3. So this is going to equal 2/3 over 1 minus r, which is in fact negative 2/3. This is what I'm finding, negative 2/3. That's a 3. And what this is actually going to give me is 2/3 over, this is 3 over 3 plus 2 over 3, which is in fact 5 over 3. And then when I multiply by the reciprocal of that, it's going to end up giving me 2/5, really is what's going to happen. So this is the sum of the infinite geometric series. If I add these terms forever, it'll converge to this. That's pretty much what it's going to end up being. And that is your final answer. I hope this was helpful to you and that you spend at least a few minutes looking over it before your exam tomorrow. And I appreciate it. Thank you so much.